Okay. I think we're going to look at some problems here that are related to geometry of straight lines. So as you can see here, we have PQ, there is PQ, there PQ is there, and we say PQ, we are told that PQ is parallel to what? To RN. PQ is parallel to RN. Now we are told that MO, where's MO? MO is equal to who? NO. Right, and then we are told that angle O is equal to 48 degrees. So this is a nice problem, guys. Nice, beautiful problem if you look at it. And now we are asked, what is the size of angle Q1? Where is Q1? It's here. Now, it's very important that when we look at problems like this, we also, acknowledge what we have been given and what we have to find, because it becomes very important to know what we've been given and so that we can know what to find. So what we've been given here is angle O, which is 48 degrees. We have also been given that PQ is parallel to RN. Okay, so that's PQ, and then that's R to the N. Then we are told furthermore that MO, now this is M, this is O, so MO is equal to who? To N, and that's O. And then furthermore we are told that angle O here is 48 degrees. So 48 degrees is there. Now we are asked to find what is the size of who? Q1. Q1 is here. Now this Q1, what is it? This angle Q1 is the exterior angle, all right, of this triangle. Currently, we only know that angle O is 48 degrees. What would be nice is if we would know what angle O, whatever that is, if we would know what that angle is, it would be great, because adding these two angles would give us the exterior angle, which is angle who? Angle Q1. But okay, of course, we probably cannot move in that direction as of yet. But from the information that we've been given, since we've been told that angle O is 48 degrees, I'm sure you can see here we are told that MO is equal to who? NO. Now that's something very special about this triangle MNO. So on the side, we're just going to do some calculations, because it's very important. Because remember, we are asked to find what is the size of angle Q1, and we've been given those options. But as we look at the diagram, we are asking ourselves the question, what can we do? So I can see that in triangle, what triangle? Triangle OMN. Look at triangle OMN. I've been told that MO, right? So I kind of want to see this separately. That's 48 degrees. That's M1 and that's N, right? And then basically I've been told that these two sides are equal, meaning in other words, MO is equal to NO. So if MO here is equal to NO there, that is very easy for me, because if this angle is 48 degrees and these two sides are equal, I can conclude that angle M1 is equal to angle N. Why? Why are we going to say angle M1? Because look at this, we are looking into the triangle. So I've already identified and said in triangle OMN, what did I say? Angle M1. Now I can loosely say angle M1 is equal to angle N. Why? Why can I say that? I can say that nicely because I've told you the triangle where I'm working, in triangle OMN. So since I've said in triangle OMN, then that means I can say angle M1 is equal to angle N. Guys, if I didn't say in triangle OMN, if I didn't state that, because remember, the minute I say this, my teacher is saying, oh, the learner is working within the triangle OMN. If I didn't say in triangle OMN, then I would have to then say angle M1 is equal to NM. If I didn't state the triangle, I would have to say angle M1 is equal to angle ONM. Right? So that's very important to note, because sometimes learners, they don't understand when can you actually identify the angle loosely. Angle M1 is equal to angle N. If I have told you the triangle where I'm working, then I can say angle M1 is equal to angle N. But if I don't tell you the triangle where I'm working, then I have to be specific about the angle. I have to say angle M1 is equal to angle ONM, and then use the little cap on top of the N to indicate the angle that I'm working on. So that becomes very important, guys, whenever you're doing geometry. Okay, now I need the reason. Why are we saying angle M1 is equal to angle N? Take note, the two sides are equal. So the reason that's acceptable is angles opposite equal sides. We say angle M1 is equal to angle MN. The reason is angles opposite equal sides. So if I was someone else doing this problem without identifying the triangle, I would say angle M1 is equal to angle ONM. And then I would also state angles opposite equal sides. So this is the difference between the learner who has told me the triangle that he's working in. He can say angle M1 is equal to angle N. And the learner who didn't tell me the triangle where he's working, the learner says angle M1 is equal to angle ONM. Okay, let's proceed. And the reason there, guys, angles opposite equal side, not isosceles triangle, it's angles opposite equal sides. Okay, now that means that I now know that angle M1 is equal to angle N, and it's because I learned that MO is equal to ON. So that's why M1 is equal to ONM. Now I can then say the following. Very importantly, I can then say the following. Take note what I can say here. I can say angle M1 plus angle ONM is equal, plus 48 degrees. Plus 48 degrees is equal to 180 degrees. What's the reason? Sum of angles in triangle. I could write that reason, or I could say angle sum in triangle, or I could say interior EINT angles of triangle. One of three acceptable reasons. Angle M1 plus angle ONM is equal, plus 48 degrees is equal to what? 180 degrees. Why? Sum of angles in triangle. Or I could say angle sum in triangle, or I could say interior angles of the triangle. Then remember, guys, look at this. Then I can say angle M1 plus angle M1. Remember, this here angle I said is equal to angle M1. So I can replace, in the place of angle ONM, I can replace it with angle M1. Why? So that I can solve for angle M1. Now angle M1 plus angle M1 will give me 2 of angle M1, because M1 plus M1 gives me 2 angle M1. Then I transpose the 48 degrees. I take the 48 degrees over to the other side. It becomes 180 minus 48. Okay, then 180 minus 48 degrees gives me what, guys? 180 minus the 48 degrees. That gives me 132 degrees. Then what do I do after that? Since I want just angle M1, I'm going to divide by the coefficient of the angle. In other words, the 2 which is multiplied to angle M1. I'm going to divide by 2. But what I do on the left, I do on the right. So then I get angle M1, which is equal to what? Yes, guys, it is equal to 76 degrees. Okay, so far so good, I would say. I now have angle M1. Right, now if we go back to the diagram, that means this angle M1 is 76 degrees. It is what? It is 76 degrees. So many ways in which I could then answer this question. Okay, if this is 76 degrees, okay, so I'm just gonna redraw this diagram so that I don't have to work on the diagram that's already there. Okay, 48 degrees is there. I have okay, very good. Okay, so this is not 76. Okay, I hope at least some people are awake here on my comment section. Can't be 76, right? Angle M1 has to definitely be what? 66 degrees. Okay, at least I know that there are people in my life, because imagine allowing me to just say angle M1 is 76. Thank you, Zama. Zama is doing some Zama-ring stuff there. Nice. Thank you. So that's M1, that's 2, that's N. Okay, you know that those are parallel. That's P, that's R. Okay, that's O. We just found M1, it's 66, so I update the angle here. So angle M1 is 66 degrees. Now remember, the whole goal was to find Q1, which is that angle there. So since the lines are parallel, I can do one of two things. I can either find angle Q2 if I want, because if I have angle M1, angle Q2 can be found as well. Why? Look at this. What letter are we forming here? And what kind of angles are these? The Z shape. Remember the Z shape? Okay, what type of angles is angle Q2 and angle M1 if we see the Z between parallel lines, right? So hopefully people are like, oh, I see angle Q2 and angle M1. We call those angles. Yes, you are right. We call them those types of angles. We call them alternate angles. All right, so I could go that direction. I could find angle Q2 and say angle M1 is actually equal to angle Q2, because I can see my Z, the angles M1 and angle Q2 are those angles that we call alternate angles. Okay, so I could go that direction. So I'm going to go the alternate angles direction and then show you another way that I could possibly go. What I love about geometry, guys, is that there's many ways to get to the answer, you know, depending on how well we have trained our geometric eye in the grade 8 and grade 9 level. So we are going to say angle M1 is equal to angle Q2, which is equal to 66 degrees. Why? Now, very important how we write our reason. We are going to say alt angles. Then we write a semicolon. We indicate the lines that are parallel. So P who? PQ, we were told, is parallel to who? RN. Okay. PQ is parallel to RN. Are we together? PQ is parallel to RN. So we know now we can update our diagram and say Q2 is 66 degrees. Okay, that's someone who's looking at this and they're like, that's what I see. Someone else who's different can basically use another way and say, no, I see co-interior angles. M1 and this angle here, okay, are co-interior angles. So they would add the two angles here and say co-interior angles, and then use vertically opposite angles. This angle with this angle. This is a straight line, that is a straight line. So this angle would be vertically opposite to that one. So once they find this angle, then they find that angle. So you see, learners, we can use various ways to get to the answer. But let us continue with our alternate angle approach here. Angle M1 is equal to angle Q2, we got 66. Now, we can see Q1 here. Okay, Q2 and Q1 are lying on a what? On a straight line. So we say this angle plus that angle, they complete a straight line. They like my protractor. Okay, Q1 and Q2, they complete a straight line. So I can say angle Q1 plus angle Q2 is equal to 180 degrees. What's the reason? Angles on a STR line. Acceptable reason. Then Q1. Remember Q1, what did I get for Q1? I don't know what Q1 is. That's what I'm wanting. Q2 was 66 degrees. And then that's equal. The addition of those two gives me 180. Now I solve for Q1. 180 degrees minus 66 degrees. So angle Q1, what's angle Q1? 180 minus 66. Right? I have a feeling that my good great friend Zama will help me with the answer there. It seems like Zama is the only one that's really going to help me with answers here. Thank you so much, Zama. Zama is Zamaring me, I'm telling you. Zama is Zamaring me. 114 degrees. Okay, so we got the answer. Okay, using this approach. Guys, if I look at this diagram, there could be many other ways to get to the same answer. All right, so I'm just going to recap again. We had a question here. We were asked to find what is the size of angle Q1. We found angle Q1, it's 114 degrees. When we go to our options, A, B, C, D, you see it's not a guessing game. We can actually locate the right answer. Thanks to Zama. Zama helped us to find angle M1 and corrected us when we were doing funny stuff with our mathematics. And Zama was able to rectify that angle M1 is 76 degrees. That error would have led to a miss error and a error here. But because Zama helped us out, angle M1 is 66 degrees, we were able to then use that 66 degrees, not 76, to then find the alternate angle, angle Q2, and then ultimately our angle Q1, because we can see angles on a straight line. This angle Q1 and angle Q2, they lie on a straight line. So the addition of both, they are next to each other. So when they are next to each other, guys, we say the addition of both. It's very important that angles on a straight line refers to when angles are next to each other. They are next to each other, they are adjacent. We add them together, we get 180. That is our reason. Then we solve. We get angle Q1 is 114 degrees. Okay, very straightforward, very simplistic. So Menier can go and circle C as the answer because the approach is 100% correct. Thank you. Okay. Okay, I'm going to do this last one before I leave, okay, because I'm on a tight leash and time is of the essence. So let's look at this one. Nice diagram. Looks very busy, but honestly speaking, it's so nice to know that even though this diagram is busy, we will unpack it and we will get the answer that we need. You see? Well, that's beautiful about maths. So we can see there, we are told AB, there's AB, is parallel to CD. So we have parallel lines here. AB is parallel to CD. Then we are told angle B2, where's B2? There is B2, is 25 degrees. It is there in the statement, it is there in the diagram. Angle B2 is 25 degrees. Angle B4 is x plus 10. There it is. We are given x plus 10. It is in the diagram, it's in the statement. Angle B5 is 60 degrees. It is in the statement. There it is in the diagram, 60 degrees. All right. So this is nice. Then we are asked, what is the size of angle who? F1. Angle who? F1. Now we need to be very, very cautious and very, very careful. We are asked to find angle F1 and these are our options: 30 degrees, 55 degrees, 65 degrees, and 60 degrees. Now we are being asked to find angle F1. So from the information we have, let's just look at the information we have. We were not told about this box in the statement, but we know that this box here means 90 degrees. This is a right angle. All right, and in actual fact, that then means, in layman's terms, that this line here, all right, this line here, if we look at F1, it would be nice if we could find ABF. This ABF will be alternate to F1. Hey, that would be very beautiful if we could find this angle here. This angle here, angle ABF, is actually vertically opposite to angle B4. So angle ABF is vertically opposite to who? Angle B4. Why? See the straight line? Yes, I'm sure you do. I hope you do. Oh, can we say that? Yes, this straight line, and look at this one. This straight line. They make these two angles vertically opposite. So the minute I'm able to find what that angle is, which means I need to first solve for x, the minute I'm able to find what that angle is, this here, angle B4, I will know what angle ABF is, and then ABF will be vertically opposite to who? Will be alternate to who? Angle F1. So in my head, I'm already thinking, okay, this is angle F1. That's what I need to find. It is alternate to angle ABF. There, that angle. This angle is vertically opposite to this one. Why? Because you see the straight line? You see that straight line? Those are the Bakajuju angles. It's the Kamagebula, Pirates fans angles. That angle should be equal to that angle, but I need to find x. I hope you guys are feeling the flow of what I'm thinking. Right? Yeah. Vertically opposite. This angle is vertically opposite to that one. So I need to first find who? The value of x. How am I going to do that? So let's take a moment and try and figure out what is the value of x and how we can go about finding this value of x. Because the minute we are able to do so, then the rest will be history. The rest will be history for us. So we are told that this is 90. But guys, I can see that here, this line here, it's a nice straight line. This one, this line, this is a straight line. But from this to that to this, that's not a straight line. So I need to be very careful. So let's find angle B3. I think we can find B3, right? We can find angle B3. This entire angle is 90. But B3 we can find. So how do we find B3? Let's do it. I think angle B3 can be found. So we say angle B3 is equal to, actually, let's say angle B3 plus angle B2 together are equal to 90 degrees. See this? B2 and B3. This box is covering from here all the way to there. So that means angle B2 plus angle B3 is 90 degrees. What's the reason? We say complementary angles. We say comb angles. Okay, angle B3 plus B2 is 90. Then we want to find who? B3. We say angle B3, B2 is 25 degrees. Then we can find angle B3. We transpose the 25, it's positive 25, goes over to the other side, it becomes negative 25. Then what do we get? We get a nice answer of 65 degrees. That's angle who? B3. So I hope you see now we have B3, it's what? 65. B3 is 65. Why? We used complementary angles because of the box, which means 90 degrees. Okay, so angle B2 plus B3 we said is 90. Complementary angles, we transpose the 25. 90 minus 25 gives us 65 degrees. Now that we have B3, this line is straight. It's a straight line, this one. So we can say B3 plus B4 plus B5. Hey, let's go. Angle B3 plus B4 plus B5 is equal to 180 degrees. Why? Angles on a straight line. Now I just want you to know, guys, that you see B3 from this line to there is B3, from there to there is B4, from there back to the line where I started is B5. Those three angles, this plus that plus this together are next to each other, common vertex, this angle plus that angle plus angle will give me 180. So let's say B3, which is 65 degrees, which I found, B4, x plus 10 degrees, and then B5, 60 degrees, is equal to what? 180. Then let us solve. 65, remove the bracket, positive times x is positive x, positive times 10 is positive 10, plus 60 degrees. We then leave the x on the left, we transpose everything else. In other words, 60 on the other side becomes negative 60, 10, positive 10 becomes negative 10, 65, which is positive, becomes negative 65, and someone must give me the calculator answer. What's 180 minus 60 minus 10 minus 65? What is it, guys? 180 minus 135. What do we get? Thank you, Zama. Zama is like on the money there. Zama is like, oh, Zama is Zamaing me big time, I tell you. Okay, so x is 45. Now we have the value of x. Do you remember, guys, that we could see that the minute we have x, it means before we can get the numerical value of b4. X plus 10 degrees, we substitute in the place of x. The 45 plus 10 gives me 55 degrees. That is angle b4, the numerical value. There's no reason there because I'm simply substituting the x value that I got in the place of x. So 45 plus 10 is 55 degrees. That is the numerical value. Now, do you remember what I said, guys, about angle b4? Angle b4 is actually vertically opposite to angle ABF. So angle ABF is equal to angle b4, which is equal to 55 degrees. What's the reason? Vert op angles equal. You see, angle ABF, you see, very important, is going to be vertically opposite to who? Angle B4. This is a straight line, okay? That is a straight line. And these angles, these lines, they intersect to form angles that are vertically opposite. This angle and that angle. B4 is 55 degrees. Angle ABF should also be 55. Then remember, when I have this angle is going to be what? Vertically opposite to who? F1. So angle F1 is equal to ABF, which is equal to 55 degrees. Reason, alt angles. State the lines that are parallel. Alt angle, you state the lines that are parallel. AB is parallel to CD. AB is parallel to CD. There it is. I got angle F1. It is 55. You see, so my multiple choice answer that I will select is B. What is the size of F1? It's 55 degrees. It's there. There. Then as I leave you guys, goodbye, you need to tell me what type of triangle is a triangle with all three angles equal. A, scalene. B, isosceles. C, equilateral. D, equiangular. Which one? What type of triangle is a triangle with all three angles equal? 1, scalene. A, B, C, D. Which one? Scalene. A, B, isosceles. C, equilateral. D, equiangular. Hey, Mabato is saying C. Stumza Stum is saying C. Ling Gomezul is saying C. Seems like we have a C affair. Triple C or 1-2 Akona is saying B. What type of triangle is a triangle with all three angles equal? Guys, remember, if all three angles are equal, okay, that means we have an equilateral triangle. Equilateral, not equiangular. There's no such thing as an equiangular triangle. Those who say, who took the name from the fact that it's three angles equal. Remember, the minute that three angles are equal, okay, we have three angles, the sum of which is supposed to be 180. So 180 divided by 3 is 60 degrees. If this is 60, 60, 60, it means the sides are all equal. So this is an equilateral triangle. Not equiangular. Don't be fooled. There's no such thing as an equiangular triangle. It's not an isosceles, because an isosceles triangle has two angles equal. A scalene, none of the sides are equal, or none of the angles are equal. Equilateral, it is C. Equilateral triangle. Okay, love you lots. I will see you guys when I see you again. Thank you for joining the live. I have to go to work. Have a great one. Follow the live creator. If you want help personally, send me an inbox message. If you want me to tutor you, I tutor at a very high price, because yeah, I'm the best of the best in the industry when it has to be done these things. So please, thank you so much. I really appreciate you joining the live. But if you want to do freebies, you can more than welcome to actually join in my live sessions when I do go on per grade, whenever that I feel suitable. Thank you so much, Zama. You are the best of the best. When you're a rock star, please, you are more than also welcome to join my WhatsApp channel. You go to my live session, go to my bio. There's a WhatsApp channel you can join. Also, there's my YouTube channel, videos that I upload of the live sessions. I upload them there. I did a geometry GEC session yesterday on multiple choice questions, and this is a continuation of that. You can find the live session I did yesterday. It was a bit longer, 1 hour 30 something minutes, where I was going through the multiple choice options, but also doing the working out, which is the culture that we need to get into as learners in grade 9. That when we're answering GEC, we don't just circle answers for the sake of circling. We must think about what is written and stated, especially with the geometry. We must do the problem solving on the side, and then when we found the answer, go and circle the appropriate and correct answer. We have sufficient time to be able to do that in the GEC paper at the end of the year. And remember, some of you want to do maths in grade 10 next year, so you can't afford to be loose, when it comes to doing the things that you need to do. I'll see you again, guys. Thank you so much. Like I said, please do subscribe. Go to my bio link, subscribe to the YouTube channel. Also, it would help if people subscribe to the TikTok page as well. A subscription fee every month, guys. It helps me a lot. It gives me that oomph to come back and again and again. So please also subscribe to the TikTok page. Subscriptions are there for the taking, and please, generosity, it helps. If you guys want to gift, please do gift whenever the situation allows. Thank you so much. I'll see you again. Love you. Bye bye. Have a great day. God bless you and be blessed.